Hey, in this video, we'll talk about query writing and metadata filtering. These are two concepts broadly used in RAG systems, and it can help you sometime improve your RAG, but they are not drastically complex or drastically interesting. So I'll just show you how it works and how you can use it in your RAG system. So let's get started. So let's first start with query rewriting. What is query rewriting or query optimization? So what happened here is that sometimes the user input may lead you to the wrong path. You may have some lexical or syntax mistake or syntax error in the user query that will fail your retriever. Or you may just have a question that's wrongly formulated. And what you want to do here is to rewrite the query to make sure that it's keep the essence of the question or actually correct any mistake that the query may have to be able to retrieve better documents. It's kind of close to hypothetical document embedding, but what we do here instead of generating fake answer is rewriting the original query without changing something. We just like fixing grammatical and syntax errors and adding a bit more context to the question itself, but still keeping the question. So it's basically like when you ask something to ChatGPT, what it does is that it's first rewrite your question into a format that's correct so the LLM can understand it better. It optimize your prompt, basically. So what's happening here is kind of the same thing. The process here is optimizing the user prompt to give better answers. So let me show you how that works. So here, for example, you have multi-turn conversation. So one user may ask something like, what is the max daily travel allowance? The LLM will answer. And then it asks something, is it the same for this specific project? The LLM answer. And the last one here is, what's the budget code for it? So if you just get this question, what is the budget code for it? If you just take this question alone and try to find an answer document related to it in the vector store, you'll find nothing that's part of the global context of the conversation. And capturing the global context of the conversation is also one of the advantages of query rewriting, right? So in this case, for example, to be able to answer this question, you need to understand that we are talking about Project Jupiter, which is part of the last conversation. And we also talk about travel allowance here. So you need to pass the whole array of conversation to an LLM and ask it to rewrite the question in a way that will reflect the conversation history and reflect a bit more what the user is asking for. And that's what you will be using to find related document in your vector store. So here, for example, if you embed the raw query, which is what's the budget code for it, what the LLM will retrieve is just generate document about budget, because you have budget in your query, and like department budget code and things like that, but not something really specific to what the user is asking for in this case, which is the budget code for the Jupyter project. Okay, so the solution is what? As usual, I'll just give you the side-by-side comparison. Here we have a simple RAG system. The user asks the raw query, we embed and research. Every question we embed and research, and it will fail as we showed it earlier. But what if we implemented query optimization here? What will happen is that you get the raw query and you pass both the raw query and the conversation history to an LLM, and you ask the LLM to rewrite the question based on what the conversation is about, and based on the context of the question itself, just in case you made some mistake in your question, the LLM can actually rewrite that. And then the resulting question from the LLM will be way more interesting for retrieval. And then you use that. The spell check and expansion is also part of the query rewriting. And then now you embed it and do the vector search based on that. So the result in our case will look like this. You get a chat history from conversation, from like what we have before, which is just basically turn 1 and turn 2. And you pass also turn 3, which is the question. You pass both of them and the raw query to the LLM, and the LLM will just generate something that will look like this. what is the budget code for Jupyter project travel expense claims? Because in the conversation history, we were talking about that. So this question is a bit more interesting for you, right? And you will get better answer to it. And then you embed this question, you do a vector search on that question, you retrieve the document, and this document in this case are actually related to Jupyter Notebook, to Jupyter project budget and travel codes, and you'll get a better answer. So that's basically the concept around query optimization or query rewriting. It's just basically giving to the LLM all the context it needs to rewrite the single question the work user is asking for, and be able to retrieve relevant documents to answer the question. So that's it about query optimization. Now let me give you an overview of metadata filtering as well, and then we'll go through the code later. So metadata filtering is also something quite important to know when you're working with a large scale data. Let's say you have one vector store. It's not usually the case, but let's say you have like one single vector store and a bunch of documents from different departments, different years, different people. You have just a terabyte of data in one vector store. What will happen is that the first single search you will make will retrieve irrelevant document. That's for sure. You will get irrelevant document from the single search that you will do. Why? Because you're mixing different documents from different years, from different departments. If someone just asks something like, what's my department budget? This question doesn't have any context for you to be able to retrieve the right document from the right department, from the right year, and So what you need to do here is to keep your documents, or in the vector store to keep your documents with a set of metadata that will help you filter it later when you are trying to retrieve the right document. So for example, you may add in the uploaded document the department, where it's coming from, the year, maybe some other metadata like created by, so you know that when you're querying your own document, we can filter and only search from your own document. Or maybe the level of access as well. So maybe this document is only for admins, or this document is only for this level in the company. So when you add all this metadata, you're now able to retrieve the right documents. Why? Because you're filtering it through during the vector search. So let me show you how it looks like. This is a simple search without metadata filtering. So you will ask a question like, show me the Q3 2024 engineering roadmap, right? So the LLM will go inside the document content that are embedded and try to find something related to 2024 engineering roadmap and give you related documents. These related documents can be some documents that do not clearly state 2024 or are not for 2024, but kind of close in terms of semantic. And you'll get that and give it to LLM to generate a response from it, and you will hallucinate, right? It will give you the wrong answer. But a good way of handling this is what? Having a metadata about the year and the department, okay? So the solution in terms of system design here is to have the user query generate the filter from the user query and the search. First the ingestion pipeline. So I can explain what happened before you embed the user query. So before you embed the user query, when you get a set of documents, you both chunk and extract the metadata from these documents, right? And when you embed the document to save it in the vector store, you save them with the metadata that are related, that are extracted from the document. It can be extracted from the document, it can be manually coded for you to know how to distinguish a set of documents from others. And when you save that in the vector store, you make sure that you link the right metadata to the right documents. And then here, when someone asks for a query, you extract the metadata from the query. So if someone says, I want the Q3 2024 engineering document, you can extract the year, the quarter, and the department from it. And when you get these three elements, you can actually filter with metadata from your vector store and do the semantic search only on the subset of data that satisfy this constraint. And you get that back, and you give it to an LLM, and it will generate a more cohesive response, right? That's what it looks like here. So same, you extract the department, the year, and others, you pass it to the LLM, and you get exactly the Q3 2024 engineering roadmap documents, right? So this will save you a ton of time debugging RAG on a bunch of documents, just trying to optimize the query and other, when you can just filter through the metadata. So how does it look like in terms of code? I'll go through the code for both metadata filtering and query optimization and show you how to work with this, okay? Okay, so this is a notebook. I'll put the link in the description for both use cases. I'll put the link for the query writing and for the metadata filtering so you can play around with both of them. So here first, we need to install our packages. And we need OpenAI keys in any case. So you need to go to the platform, OpenAI platform, extract your API key, add it to the secret so we can use it later on. This is where we use it actually, okay? So when that's done, we'll be running this next. We're running the OpenAI, the import of document next. I have a set of documents here, and if you see, I ordered them by, I actually added a lot of metadata to this document, like year, department, quarter, and type of documents, so I can filter through it later. You will see that a simple search will fail, and why it will fail, and I will show you how the filtered data work well. So this is where you actually put your API key, and you have here a set of documents. You have metadata like department, finance, quarter to filter through it, right? So if we run this cell, and we run this, make sure that you're using the right vector store, because the in-memory vector store, for example, doesn't support metadata filtering. You need to make sure that you have the vector store you're using support metadata filtering. So you run this cell, done, okay. So here now, we can run the query, which is show me the financial report for 2023. So if we run this again, you will see that we are getting manual from 2022. We are getting manual from 2022 twice, actually. Why? Because we are not doing any filtering, and this may have more keyword in 2022 than 2023. And if you just have the RAG retrieving the document right away, you will get the wrong context, and the AI will hallucinate and give wrong answers. So what happens here is that, okay, what if we filter it by here now? Because we are looking for a document for 2023. So if we run this, you will see that we have now here the Q3 prediction for 2023 and the Q3 prediction promising for the projection finance and from different departments, right? So both documents are actually Q3 2023 documents, which is what we're looking for compared to what we got before. So this is how metadata filtering can basically save your life and save you a ton of hours debugging and improving query in the RAG system. So, okay, so next let me show you how query optimization works. Okay, so here we have a simple import from a set of libraries. We'll be doing here. Let me clear all the output so we have updated one. So here, same thing as before, we import the right libraries and everything. But here now we have a set of documents, basically about a lot of things, about just the quick whatever jump and the Eiffel Tower and a lot of other things. So we embed all these documents in the in-memory vector store. And then we have a simple query here saying, show me interesting things to see in the West. West here being the Western world, like, you know, Europe and US and others. So this is how a user will actually type something. You know, you are seeing some kind of mistakes here. And that is what you will expect when you build a production RAG system. So if you run this and get the raw query, you will see something pretty funny. Is that we're getting here, the capital of France is Paris or whatever, and the quick brown, you know, unrelated documents, completely unrelated documents, just because the context is not well written and the question is not clear enough, right? So what we will do now is rewrite this query and give it a more distinct and clear meaning, which is here, interesting attraction in the West. And if you run this again, you will see that you're getting something about the clock in London and the capital of France, like Paris, and the center for art and whatever. So you will see that this is a bit more close to what you're looking for. Just because you like correct the query to make it clean for your retrieval step. And this will give you better result, way better result. Yeah, so that's all I wanted to share with you today, query rewriting or query optimization and metadata filtering. I hope you learn a lot from this. If you have any questions, don't forget to put them in the comment section below. Don't forget to subscribe. We'll be doing a lot of system design and building AI engineering apps, AI apps on the channel. Yeah, so just thank you for watching and see you in the next one.